Okay, so 5.2 is, thank you. All right, 5.2 is a section that is not really going to require any written work. It can't be done on Desmos. It can't. It's all done in your mind, which makes it a little difficult to teach and correct if you're not getting the correct answers, because it's really like visualizing what has happened. There's some tricks I can kind of help you with to answer some of these questions, but it's really looking at being able to visualize these different things. So, a cross section is a surface or shape that would be exposed by making a straight cut through something, especially at right angles to an x-axis. So, for example, to start with one that's pretty straightforward. If I had a cylinder, okay, I could cut it several different ways, okay? What the two that you're going to be asked about most often are going to be problems where you're either making a cross-section perpendicular or parallel to the base or perpendicular to the base, although it can ask you about slanty ones also. So if you take, like if we had this here and we took a cylinder and we cut it perpendicular to the base, so like cut it in half. The question is, what shape would you have there on the bottom, like when you cut it, what would you have? So if you cut it parallel to the base and it is a right cylinder, meaning it's straight up and down and not like bent over to the side or something, you would just get the same shape as the base. So think about like whenever you go to the store and buy the log of cookie dough, right? The pre-made cookie dough. Everybody know what I'm talking about? Have anybody used that before? Right? That is your cookies. It's a big log of cookies, but you make a cut, right? And it cuts it into all these little tiny cylinders that are your cookies, right? So that would be a cross section that you're doing whenever you take those sides there. Now, what shape would you get if you took that log of cookie dough, turned it up long ways like this, and cut straight down through? No. Well, you're thinking like a step ahead. What shape, like where your knife went, if you cut it, it'd be long, right?
Rectangle.
And you would have a rectangle shape. Like if you just look at that bottom. Now, if you took each one of those and chopped it up, all your cookies would be like semicircles, right? But it would be a rectangle. If you took your cookie dough and for whatever crazy reason decided to just like slice that cookie dough right down the middle, then if you looked at that cookie dough, it would be a rectangle on that surface, right? So if we cut this right here, this shape right here would be a rectangle. Okay, so here's some of the types of questions that you may get. So, example 1. What is the vertical cross-section going through the center of the figure shown? And some of those words got cut off on yours. I apologize for that. That was I set margins thinking it would help things. It made it worse. If we are talking about a vertical cross-section of this, yeah. So, I think there can be two answers to this, actually. So, if we cut this, like, straight down the middle, right? So, if we, like, cut that, it'd give us, like, something like this. Right? And I agree you would get a triangle there. That would be a triangle. Okay, so triangle definitely can be an answer. I don't think it's the only answer. What about if I cut it like over here? Trapezoid. Oh, it does say center. Sorry, I did not read carefully. Okay, so. Thank you. I was thinking it was a bad question. Oh, so William has a good question too. Like I cut it sort of like straight on, right? But you could cut it this way and it would still go through the center. If you did that, you would be cutting like here, like that. What shape do you still get if you do that? Still get a triangle. Okay. Like if you cut it, yeah. That is going to be more complicated than I want to deal with. Like cut it like this. It's a trapezoid still, I think. Yeah, trapezoid. I mean, like. Oh, you mean like? Yeah, you could cut it that way, like this. Yeah, I guess that'd still be through the center. That triangle. But any. Yeah. All right. Okay. So, any way you cut this through the center is going to be a triangle. If it didn't say center, you could get trapezoid. Could you get a square? Not with a vertical. Not with a vertical. What about horizontal? What would you get if you cut it horizontally? It would be a square, right? It'd be the same as, that'd be parallel to the base. So you would get the same shape as the base, even that's kind of a weird way that's drawn. All right, so triangle for that one. Okay, I'm going to read the second one to you. I want you to silently, without saying it out loud, choose one of these here, and then we'll see what you guys think. Daniel cut the corner off of a cube as shown in the diagram below. Points A, B, and C are the midpoints of the edges of the cube. What type of three-dimensional figure has been cut off? So it's asking you what the piece that got cut off looks like. We only see what's left. It wants to know what the piece that looks like. Up without saying anything. I want you to choose one. Everybody, shh. Everybody choose one. Shh. All right, everybody pick one. You got to pick one. You got to commit here. Everybody pick one. A cone, a cube, a triangular prism, or a triangular pyramid. All right. Has everybody picked one? Okay. How many of you think A? B? C? Okay, we got 3 or 4 for that one. Okay, D. D's are correct. Okay, it's going to be pointy. Triangular pyramid. Okay. All right. Okay. 3 is, to me, even trickier than any of the ones we've done so far. A right circular cone is represented by the drawing below. Here's our cone. Which figure could not be a cross section of a right circular cone? Okay, nope, don't say it. Everybody choose one without saying it out loud. Think about it for a second. Think about cutting it different ways. You could karate chop it in half. Okay? Check with your partner and see what they've got and see if you think the same thing. All right. Let's vote. How many of you think A? Good, because it's definitely A is a possibility, right? What about B? C? D? Good job. All right. Now, A is pretty easy to see, right? You just cut anything parallel to the base. How would you have to cut it to get C? Like this? Like how would, if you karate chop it this way, you get a circle. How would you karate chop it to get C? Vertically. Right on the point, right? You would need to karate chop this right in half. Right there on the top. How would you karate chop it for B? No. That's going to give you a circle. This gives you a circle. This gives you a triangle. To get an oval like that, you would need to karate chop it sideways, like at a slanted angle. There. But no matter what you try, you're not going to get a rectangle out of this, right? So the rectangle is not going to be the cross section. Okay. All right. Okay. Here is another idea that we're going to think about. Okay. New idea here. It is no longer asking us about cross sections, but it's asking us about rotations. Okay? So, what three-dimensional figure do you get when you rotate a rectangle 360 degrees? So, if I have a rectangle right here, and I rotate it 360 degrees, really it could be around any line, but let's say we just take it and spin it around this line right here. What shape we get? And this is a second question, so these are not your answer choices. If you take that rectangle and you spin it around, so like, I wish I had a good rectangle. No, you don't. Okay, so like think about this. You got a rectangle. If you spin it around like that, okay? Alright, like if I could spin this really fast, if I could flick it and it would spin really fast, it'd look like a solid, right? It's a cylinder, right? For that. It is asking when you spin it around, so like if, quiet please. Okay, if you spin it around, not like it's staying a rectangle, because it doesn't change this shape, right? But if we spin it around like this, and as we spin it around, like each piece still remains. So we are creating something here. I don't have a cylinder, but I can show you with this over here. Okay, so here's a picture of it. Imagine that you don't have this weird shape at the top. So imagine you're just looking at that part, right? So that is roughly a rectangle. For kids, it is a rectangle. If I take that and I spin it around like this, so that that piece is building a 3D figure. If I spin it around like that, like ignore the yellow orange part here. This is a baby bottle decoration for a shower, but that would make a cylinder, right? So does that help you guys see what we're talking about doing here when we're talking about rotating? Yeah. There, you're taking that rectangle and spinning it around, so it makes a cylinder. All right, so if I have an isosceles trapezoid, okay, first of all, we need to know what in the world an isosceles trapezoid even looks like. Two sides the same. Okay, so we got an isosceles trapezoid, which means it looks like this. Okay? And we're going to spin it around its longest base. Are any of those answer choices even right? That's C. Yeah, it is C. Mine just, okay, let me draw. All right, so mine, I would spin it around this way. Right, that middle part is like a rectangle. Right, so it makes a cylinder in the middle. These two triangles on the sides are going to make cones. So it would be C. All right, one last thing. I know we got just a second. All right, the last thing is a net. Right, so this is just like a pattern where you could fold it up. All right, so I've got 3 different nets right here. Which one of these nets is a cylinder? Number 1. Okay, which one is a triangular prism? It is 3. The prisms have rectangles as their sides, okay? And that means net 2 is your square pyramid, okay? All right, you need to finish up that Desmos classroom. If you have not, I've extended the deadline so you can still get credit for it. Make sure you finish that. We will do some more practice with some problems for this later.